Okay, hello guys, this is actually my first video doing this horizontal screen questions. Now let's look at this 4-unit question from North Uni Boys. Hopefully you can see it. Let omega be the nth roots of unity, but I don't like Greek letters, so let's just call it W. We can assume this identity, but assume you can prove it because everyone basically knows how to prove it if you're a competent extension 2 student. And the first question is to also show this, and I have got two methods here, and I would strongly recommend you to do method 2. And the method 2 is brute force, which is you multiply the denominator to the other side and you expand it out. You expand it out like this, and then you can cancel it. So you can use this equal to 1, which is by definition, and then you equal to n, and then you basically divide it to the other side again to get it. So it says hence or otherwise, so this one is obviously otherwise. And how do we do hence? Hence is we let s equal to that. Now it looks like geometric series, although it's not, but we approach it using the same method, which is to times the r times the term, the quotient of each term. So you time it by w, and then you can basically minus these two to get this, and then you can use the hence example here, that is this equal to 0, and then you know that w to the power of n is 1, so it's -1, so you know the result here. Now the first question should be easy. The second question, it's not easy. I mean, it's not super hard as well, because I've seen exactly the same question in James Rules. This question I've seen it in James Rules. So it's saying you should first express it as a product of its factors, and then you should deduce this result. So if you want to know a product, or you need to know all of these roots, right? So this is basically saying do it by factor theorem. So you need to find all the roots, and it's easy to know all the roots are 1 w squared, etc., etc., because if you plug it in, it's always 0. And then you already factorize it. Now you basically want to derive this, and it looks remarkably similar if you can plug z equals to 1, but you can't, because if you do that, both sides equal to 0. So you will want to actually divide it on both sides. So you get this after you divide this, and it's a very common result to divide this by this. You should know it, and then you can plug z equal to 1, and then you get the result. Now the problem is, if you divided this in both sides, then it shouldn't be 0, right? But if we let z equal to 1, then it's exactly 0. So there is a bit of problem in this proof. However, when I do it in James Rules, they did tell you why, although I don't completely understand. North Uni Boys, they don't even mention it, and even in James Rules, they explain it, but they don't expect you to know how to explain it, so it's not in the marking criteria. And so you don't need to explain it. The way you explain it is that the number of roots fit. Here, before divide you have n roots, after divide you have n minus 1 roots. So now let's look at the third question, which is where it becomes a little bit difficult. You need to find p dash p over p. So differentiate this should be, I think it's a little bit hard, because we just learned for the product of two functions, but it's multiple functions, so it is a bit hard if you haven't come across it before. And technically you shouldn't be expected to do differentiate in a complex number question, and this is exactly what James Rules very stress about. Their trial paper explicitly says you cannot use differentiation, because someone trying to derive this, they use differentiation, marks are deducted, and it looks like you can use differentiation, right? It looks like differentiation. If you integrate this, it will be w to the power of n, so it looks like it's differentiation, but you can't use it because you haven't learned how to differentiate complex number functions. And let's look at this. So the way we find the derivative of this function is that we derive a function. We find the derivative of the function first, and then keep the rest alone, and then we find the derivative of this, and then we leave the rest alone. Then we just add all these up, which is like this. So I differentiate the first one, then I differentiate the second one, then I differentiate the last one, and I add them up all together. And then because it's a linear term, it just becomes 1, and after I cancel the like terms, I will get this, which is the required result. So how do I do b? Very apparently I will plug in z equals to 1, and actually if you see this and it says hence, you should know that you can kind of guess part A if you're very lost. You just let z equals to 1, because there's no place of 1, and they must substitute it inside, so it's kind of like reverse engineering. And b is when you plug it in, you get this result. So the pz is equal to this stuff. You can plug in 1, but you don't know the value, so you need to make it like this. It's from the second question. We already know this, okay? So where do we do this in the second question is that when we try to divide z minus 1 on both sides, we already proved this identity. So you have this identity here, and then finding derivative and actually plugging in 1 would be easy, and then we can just get this result. So it's a comprehensive, difficult, complex number question. I think if you know this, you will do any complex polynomial function questions. You'll be able to do it most definitely. And extension of the product rule. Okay, so you find the product of one, then you do the other one. You find the product of one function, then you multiply the other ones, you leave them alone, and you add them up all together. And you can prove it by induction if you're interested. You can pause and see, and you can also generalize the what's it called, chain rule as well. So actually, this one I wrote here is wrong. It should be not this. Sorry, there should be an ellipse here. So you should actually, it's really, don't look at this, it's not true. If you want to find the derivative of this, you just literally, it's like peeling an onion. You find the derivative of the first one, and you find the derivative of the second one with the rest alone. You differentiate the mother and leave the baby, and then you differentiate the third one, and you leave the rest alone, and you just multiply them all together. It's like this, right? If you want to find this, then you just find the first one, and then leave the rest alone, then find the second one, and leave the rest alone until you reach the last one. So this is proved by induction. You can also prove by chain rule. So you just do some substitution. It's quite clever. You can also pause and see, but I'm not going to expand because I do not think that it will be in an NHS exam. It's most probably just for fun. And hope you enjoy the question.